Hi, good afternoon. After a long spring break, we are here again. My name is Levent, and I'm with UTA Planetarium Director. And today we are going to talk about some updates about night sky, and then we'll take your questions and comments if you have any. All right, so let's start with the night sky. So we are in the spring, so there are warmer evenings, and after the daylight saving time changes in the time, so now the sun sets at a later time. So and after sun sets in the evening, do I really see the black hole in my background?
You really see the black hole in your background.
This is we were doing field trips this morning, and one of the question came up during the field trips about black holes. So we visited a black hole with the kids, the large number of kids. They were curious about black holes, and that's why the black hole, the picture of black hole, is stuck behind me. I'm not sure if you are seeing my office or the black hole. But if you are seeing black hole, this is what it is. This is not going to be visible in the evening sky. So this is going to be going away soon,
anyway.
hopefully. All right, so we would like to come back to Earth and start with the night sky. So what is in the night sky we can see tonight? I just wanted to give a little update after the evening. So there are bright stars coming up, and one of the most noticeable constellation of tonight is going to be up in the air nearly in the south direction, the Orion constellation. Well, the constellation features a lot of great things. So this is the constellation view. If we would like to see it, imagine some lines between bright stars, and the imagination was the Orion is a hunter, a big hunting man in the sky. So rather than the bright stars, there is one great feature right below the belt of Orion. There is a fuzzy object located right here. This is one of my star party favorite because it's a vast amount of gas and dust located in the heart of Orion. So this gas and dust, mainly hydrogen and helium, this is making stars. This is a star-making region. Astronomers and astrophysicists like calling this a stellar nursery because all the stars are newly formed stars. Yes, the stars are formed out of this dust. So star-making dust is located in the Orion. You can find a lot of similar objects in the universe, in the galaxy. Again, this is called nebula, and nebula means dust. It's a Latin word. So this particular one is Orion Nebula. And one of the things you would immediately see in the sky is right above my head over here. It is not going to be this small in the real sky. It's going to be a lot noticeable because it's a lot brighter. It is the moon, the natural satellite of our Earth. All right, so yeah, Richard. Hi, Richard. Is it M1? No, it is not M1. I don't remember the M designation of the Orion Nebula.
It's 42. M42.
Yes, that sounds about right. M42, sir.
M1 is the Crab Nebula, and it's located in Taurus the Bull. So you could see that tonight. Gonna need a bigger telescope, though, I think.
And also would like to say hi to Kurt. Black holes suck. I don't know why you think this way. Black holes are cool, I guess. Black holes are mysterious. Black holes are something we need to understand to do cool things like time travel, like long distance travel in no time, right? So, all right. So we were talking about this great thing over here.
Poor black holes.
So here's the moon. Moon is showing us phases. Every month it is going through a phase cycle, and the illuminated area is changing on the moon's surface. So that's what we are calling moon's phases. So this is going to be nearly full moon, not exactly. You can still see some dark areas, but in a few days, just give it a few days, it will be full moon for sure. And here is another cool thing in the sky if you would like to see it, and it is located right here. It is Mars. Yes, you can see it for yourself. It looks like an orange dot in the sky, and if you have big enough telescope, small telescope is not enough for Mars, but if you have big enough, you can see Mars for yourself. Of course, you will not be able to see in this detail because you need spacecraft or orbiter camera to be able to see with this detail. Mars is a dry desert, and I think we have some updates from
big
Mars
updates.
Perseverance.
We got lots of updates, so let's switch you over to the update setup.
All right, so let's get some updates about Mars. So we are flying a drone on the surface of Mars now. This is called Ingenuity. So Ingenuity, as we said before, that was carried with the Perseverance spacecraft. So the spacecraft released a rover and this drone. This drone was not tested yet at the time of our last program, but I think there are some testings underway, right, Jim?
Yeah, absolutely. So we've tested several things on it, but I think the exciting thing is on Sunday they finally dropped the box on Ingenuity. Let me move my face out of the way just a little bit for you guys, so I'm not blocking Levent here. So we'll just go ahead and drop me out of the way, and then I'll send Levent over. We're going to show you guys a video of what it's supposed to look like on Mars. We didn't get a live video of it dropping the debris shield, but we can watch what it should look like, and I think it'll be kind of neat to jump there. So let's go ahead and jump straight to this, and then we'll get it started for you. So there won't be much in the way of sound, but you do get to see it, so whatever that's worth. So exciting. That's really it. It drops it out. It hasn't done any of this other stuff yet, but this is in the coming days. It's going to pull the whole thing out. It unfolds, and to quote NASA, we have some reverse origami to be done to get the full drone unloaded completely. Certainly interesting, though. Anyway, so we showed you guys what it should look like. Now let's show you what it really did look like. So it popped off its little shield, and we have some different views of the little shield here. As you guys can see, it's kind of neat. Levent, you mentioned it looked...
It looked like the oil pan, the oil change pan that
really
we put on their cars.
It definitely looks like an oil change pan.
Well, they will test the drone. The importance of drone is, as we mentioned before, this is going to be the first time flying a drone on the surface of another planet. And drones are much faster devices than rovers, because rovers usually roll at a very slow speed, and also there are a lot of dangers because the terrain is not smooth on the surface of Mars. They can easily get stuck on a rock or sometimes sand trap, like the Curiosity rover got stuck to those. Spirit and Opportunity did, and the Pathfinder was also stuck on a rock at the end of its mission. So there are a lot of dangers for rovers, but for drones, they can fly faster. And also the main design of this drone is to guide the rover to an interesting destination, because for rovers it just rolls and goes to some place, and then take the pictures and video, and then we can find out whether that place is interesting or not.
Pretty hard to imagine, seeing with the rover for very far, right? You don't have a good view of anything. You're stuck really close to the ground, but having a little drone or helicopter that can get some air and have a better look, hey, that you're going to come up on this debris field and so on and so forth, could be really helpful. No doubt about that.
And also, I would like to add the engineering challenge. So even flying drones on Earth is challenging, but also there's a significant time delay between the drone and the controller. So, and I don't know the technical details, because I know in the most modern rovers, they are not controlling the rovers directly from Earth. There is some intelligence built in the rovers. So they are making decisions as they go. You cannot just control everything from Earth because with the time signal delay.
Yeah, 14-minute delay.
Exactly. I mean, you
That's
give a
little late
command.
if you're gonna hit a tree.
You've seen a threat. There is like a big sand trap ahead of you, and you just pull the stop, and it takes it 14 minutes later. So that's not going to work.
Too late for sure. We have an image here. Two things to mention. We'll get to your comment in just a moment, Kurt. But this is the expected area. So the rover's gonna pull up to a safe location, and then let the drone go free, and it's gonna do its first little quick flight test. It'll be really short, but its estimated range of the drone is more based on time. So I think the drone has like a minute to fly. It can fly for like a minute, take a peek, and then come back. What altitude will it be flying? Pretty low to the ground. Just like on Earth, the atmosphere gets thinner as you get higher on Mars, and the atmosphere is already like 2%. Levent, it's nothing compared to Earth.
Yeah, we cannot breathe on Mars, and that's a problem for helicopters too, because as the air gets thin, the lift they can provide is very low. Well, drones are very light devices anyway, but so it's going to be flying low. And again, this is going to be a test. Well, one of the other question from Kurt is what's the life expectancy? I don't know if any life is expected for the drone, but again, this is a test mission, and after this test, when they send another drone, it will have a dedicated mission and dedicated plan and life expectancy for the drone. This is just a test run. And in the test run, you can expect anything. It can be very short or very long. Like most modern rovers on the surface of Mars, they passed well beyond their life expectancy. Like they were designed for 6 months and they ended up living for like 8 years. So that's much exceeded their life expectancy.
We can definitely hope that it lasts that long, for sure. Just what this image is that Levent's sitting behind, this is the real view of where Ingenuity's airfield is going to be. So looking out that way, you can see this is where it will actually be flying, relatively flat, relatively safe. And if something goes wrong, they can still get Percy over there to take a look at the poor dead drone if it does. But, it's not going to. It's going to survive. But I just got a comment from Jennifer, who's behind the scenes helping us every one of these things. She informed me that the first test flight should only be 20 to 30 seconds, so they're just going to start it up.
And we need to take her word. She's an engineer, right?
Yes, she's an aerospace engineer, so graduate student here at UTA.
Well, she's an aerospace engineer, so I would take her word if she says something.
Yeah, you guys don't get to see her, but she's here every week, always helping. Anyway, let's see. We have some more stuff. So, in regards to that first flight, it's kind of crazy how this whole drone thing works and how it gets itself done. So we're gonna go a little bit more into that. It's tiny. The drone's only 4 pounds, and when it flies its first time, it's gonna capture like 30 images a second. It's gonna do lots and lots of imagery to test everything. And this first little short flight shouldn't drain its battery. And you guys might be surprised that it runs off of, as you might guess, it's just lithium-ion batteries, so nothing too crazy. Anyway, here's kind of what it's going to do. This is a low-quality image, but it's all that I could get from JPL. What can I do?
Well, was it the third grader asked the question today why we are not going to the moon anymore?
Yep.
That's all because of this. Moon is not interesting anymore. There is nothing that you can do a lot further on the moon, but the Mars is very interesting. So my answer was the scientists and engineers, along with the funding agencies, they are wanting to invest their time, energy, and money into finding new things. And new things are potentially on the surface of Mars. So yeah, on the surface of Mars, we know there are no signs of life, but what we are looking for, and especially what Perseverance is going to look, is underground, because we are trying to find maybe a potential even like a mold is going to be a big one,
Mm-hmm.
or a bacteria is going to be a big thing,
That's
big
probably
discovery.
what we'd hope.
So this is what we hope. Mars is dry on the surface, but Mars may be wet underground.
Okay, speaking of going to the moon, Levent, we have more updates from not the moon but Mars, but it's moon related. This image, which I'm covering up, so please just get rid of me for a second. They decided to take little clippings of the spacesuits they're going to use in the Artemis mission, which is going to the moon, to test them. So they're on the surface of Mars. This is underneath Perseverance. We got the first image of it today. I thought it was super interesting, at least for me personally. Pretty fantastic. And we have an explanation of what they are. So I'll go ahead and shoot this over to Levent so he can sit with it and explain this. This is kind of neat. Each of those little pieces of fabric is different chunks of the spacesuit.
Mm-hmm. Well, the spacesuits are very high-tech things. Well, I mean, they are not just like thick suits. They have amazing technology in them, because in the space environment, it has to keep certain temperatures, certain pressure, and also necessary air. There was a long time ago a great spacesuit conference by NASA scientists, and they explained many facts about the spacesuits. And also, they need to be strong enough for UV radiation from the sun and for different environments. So it is showing the different sections and different materials. But I have slightly different opinion on, even though it seems like they are testing spacesuits on Mars, and hopefully someday there will be people sent Mars. But I don't think this is going to happen very quickly, because the reason is sending robots. Robots can do everything on the surface of Mars that an astronauts can do. They are very capable of, and you don't need to bring robots back. You have to bring astronauts back, right? I mean, some people may have different opinions that, well, there may be some volunteers who may just stay there, but I think you want to bring those guys back. So bringing them back is a whole different game, whole different engineering, and whole different science.
Yeah, that would be a real challenge. The trip to get there is really long. The trip to get back is really long. You have to have supplies to do. That's a lot of supplies.
I mean, think about robots. Just Arlington, I heard, started those self-driving cars yesterday.
I got behind one on the way into work today.
Hey, you just call a taxi, and I heard for a while there will be some drivers. I mean, not driving the vehicle, just observing the vehicle. There will be people inside. But the cars I see in the tests, they are driving themselves. So that means in the future, many driving jobs will disappear from the surface of Earth.
We have arrived at the future.
Because we have cars, taxis capable of driving themselves, and nowadays you don't even talk to a person to call a taxi. You just use your app, and the taxi comes to your exact GPS location. So I mean, why not use them on the surface of Mars? I think it makes a lot more sense to do that.
Definitely, especially with all the smart technology we have with self-driving and Ingenuity, the drone, has to do all that. It has to make all of its own decisions. Hey, the wind changed. I got to change, so on and so forth. So it will be really interesting. We have one more update that I think is important to bring up with Mars Perseverance, and that is something we're not going to show you. Mars, mostly because you can't really show it. The Perseverance rover did a first. It actually brought with it a microphone, and it records sounds, which is... It seems like a small thing, but it feels really connecting when you listen to them. And when I was writing this stuff up, I thought, do I make Levent listen to this live during the live stream? And I listened to it, and I have to tell you guys, no, we're not going to listen to this on the live stream. But We will go ahead and put a link if you want to listen to it. It's pretty neat. It's like 16 minutes of audio of Perseverance driving forward, and lots of clinking and clacking and whirring of motors and interference from other instruments. It's interesting to say the least. I'll be excited to hear the microphone when they let Ingenuity fly. I don't know if you guys know this, but Ingenuity is busted loud. It is so loud. Its blades rotate at like 2,500 RPMs, which is just insane for a drone. But it has to, because there's no atmosphere, so it has to have some enormous speed in order there to be any lift at all. So I'll be interested. Maybe we'll play that sound for you guys, but not the wheels. You won't like it, Levin. I'm sorry.
Well, isn't that how we advance the technology in engineering? Because I mean, if you do same thing over and over, you are not advancing anything. I mean, you can maybe make it like more economical, maybe more efficient, but certainly you cannot advance. To advance, you have to do something which is undone, and this is flying drone on a different planet's surface, especially the planet that has a significantly thinner atmosphere. Well, this is going to advance the engineering. And years ago, I was giving a presentation about why do we care about NASA? Because what NASA brought our life. And I was giving some examples, like, for example, power tools. The battery-operated power tools were made for actually space missions in the first time, because you cannot just take your electricity or wires to space and so on. And then like many unbreakable glasses, for example, made for spacecraft in the first place and then migrated to our daily lives.
Unbreakable glasses?
Yes, unbreakable glasses. First time.
What about Tang?
Yeah, the first time they were designed for the spacecrafts, particularly Apollo programs, Apollo spacecrafts windows, because they didn't want any like a small meteor or rock hitting and breaking the glass and significant, especially making a hole. So
yeah, that could be a bad
that's when they came up with the laminated glass idea, and now we use it in the windshields of cars and many other things. Laminated glasses. Skylights are made of laminated glasses. So and examples are too many. And I was going through the list during my presentation. Bottom line is just doing these kind of things, testing these kind of things will bring new technology or advanced technology in our lives.
So that really brings up a good point. I don't want to give the person credit per se, but in one of the tweets that I brought up just a moment ago in the browser with you, the comment below, which was out of view of any of our viewers, it said, "Please, can you tell me, how does this help life on Earth at all?" And it's one of those questions that kind of like frustrates me, because it's not a question. I don't think it's just not a valid question, in my opinion. But what's your take on that? How would you respond to that, Levin, if somebody approaches you during a planetarium show, which is something that happens, and hits you with a question like that? What do you say?
Well, these kind of space missions in general, the list is too long, how they can help, because there is like a whole big space industry, and not only the technology advancements, but also like the drug manufacturing. And also the testing like drugs and the different plants and so on. There is a whole big benefit of the space missions. Otherwise we wouldn't do it, right? I mean, the decision makers would say at one point, hey, this is just too expensive. I think we had enough playing around, so let's just stop spending money on those. But no, there is certainly benefits of to our everyday lives with these space missions, and particularly Mars. The findings about Mars. Well, we don't know enough about our planet yet. for one recent example can be given as like a global warming. Why it still is in a big discussion? Well, I'm not saying global warming is non-existing, but we are still trying to find and understand the data about global warming and at what rate it is going to affect us. Well, to understand our planet, just by looking at our planet only, we cannot understand the planet. So we have to explore and investigate other planets as well. Pretty much like, if you just see one person, you cannot understand humans in general. So you have to, see many people to understand the different characters and everything. So Mars is, for example, there are questions on Mars. Mars dried up. Why? And what happened to life? There was like signs of Mars. And more interestingly, we said here before, it seems like we cannot really explain for sure and complete the theory 100% that how come the life started in the Earth in the first place. It seems like the life started on Mars first, and the question is, what happened to the life on Mars and how it migrated to Earth?
It would be an interesting thing for sure. I think honestly the answer to the question is like exploring is in our nature as humans. If you can't stop us. No matter what's going on, all the bad stuff, all the problems we have to fix, we're always going to explore. So I don't want to say get over it, but I don't know. That's what we are. Anyway, Kurt got a really good point, really good question. Why are we so consistent with sending wheeled rovers? They are magnificent terrain-crawling hexapods and arachnid-style robots. That sounds terrifying. We can send that would cover a lot more terrain more quickly. What do you think about that, Levin?
Well, I'm not an engineer, but my guess would be it is very efficient and simple design for wheeled, because you have to only use electric motors that spin in one direction, or maybe the two directions, like a spider type legs and things like that requires more like a balancing sensors and more motors in action, and the coordination between them and the software would be very complicated. I think the wheel is just a simple design, and especially on different planet surface where you cannot maintain your vehicle, I think you are looking for simple design, because there is a saying that anything that can go wrong probably will go wrong on the different planet surface.
I gotta be honest, Kurt. I actually really hope we never see arachnid-style robots on the surface of anywhere. I don't want to ever experience one. That sounds like no fun to me.
Even was a walking simulation or walking robot was a big deal. Big U.S. institutions, universities were working on those. So, I mean, they can do a lot of intelligent wheeled robots. But making a robot standing on 2 feet and walk required a great coordination. And you can actually think like what our brain and muscles do by make us standing and walking and running. It requires a significant coordination of the muscles. Of course, it is done by brain, but apparently making a machine to do that is extremely difficult.
We have some ridiculous images. I'm gonna try to get this up with you just because we don't have too much time left in the live stream, but this is important. Here, I'll put it up here. These are ridiculous here. It's not a two-legged one, but those that you can kick over and they test. I just feel like when they finally get smart enough to respond, they gotta be furious. You've been kicking me around for the last 5 years. Not okay with this anymore. Gosh.
Well, I hope you enjoy our live streams. If you do, please comment or like us, and we'll be here next week again. In the meantime, if you have any questions, send it through the Ask Astronomer form on our webpage, and your questions will be answered in the next week's video. For now, see you.
See ya.